morning, madam. My name is Priscilla Mo Sinsian from class DSC 1A. My car matrix number is 20 DSC 25F1067.
Hi, my name is Rachel Dia. My matrix number is 20 DSC 25F1057.
Hi, my name is Ferdinand Sane Anak Nangkai. Matrix number 20 DSC 25F1019. I'm from DSC 1A.
My name is Natalie Jalipang and my matrix number is 20 DSC 25F1033.
Hi everyone, my name is Fabian Ferramaya Anak Leman. My matrix number is 20 DAC 25F1031 and I'm from DAC 1A.
In this presentation, we will be analyzing two types of data using descriptive statistics. For question 1, we will work with group data where the students' height are organized into classes. For question 2, we will analyze ungrouped data which includes the individual income values of the students. We will compute the measure of central tendency and dispersion, and also use a box plot to observe how the incomes are spread. Through both questions, we aim to understand the data more clearly and interpret the patterns in a meaningful way. For the mean, I use the group data formula. I multiply each class midpoint by its frequency, added all the values together, and then divided the total by the number of students. This gives us the average height for the group. For the median, I use the median class formula. I identify the class where the median position falls and then apply the formula using the lower boundary, cumulative frequency, class frequency, and class width. This helps us find the height value that lies exactly in the middle of all students. For the mode, I use the model class formula. I selected the class with the highest frequency and applied the formula using the frequency before and after the model class. This gives us the most common height range among the students.
Okay, so now I will explain about quartile, variance, and standard deviations. So the formula was already shown in this slide. First was quartile. The third quartile was found using the group data formula. First, the positions of third quartile was calculated as 3/4 of the total frequency, which is 75. This value falls in the class with a lower boundary of 169.5, a cumulative frequency of 73, a class frequency of 16, and a class width of 5. Substituting this into the formula gives a third quartile of 170.13. Okay, second is variance. Variance was then calculated by dividing the total of square root frequency, which is 5075, by the total frequency of 100, resulting in a variance of 50.75. And the last one is standard deviations. So the standard deviations is the square root of the variance, which is 7.12.
To calculate the mean, added all the values together and got a total of 406, then divided by the number of individuals, which is 10. This gives a mean of 40.6. To calculate the median, arrange the data in ascending order. Because there are 10 values, took the average of the fifth and sixth numbers. The fifth value is 33 and the sixth value is 35, so the median is 34. Mode is the value that appear most often. In this dataset, all values are different and non-repeat, so there is no mode. For the 25th percentile, 25 over 100 times 10 plus 1 equal to 2.75. This falls between the second and third values in the ascending order list. Those values are 28 and 30. 25th percentile is approximately 30. The 50th is the same as median, so the 50th percentile value is 34. For the 75th percentile, 75 over 100 times 10 plus 1 equal to 8.25. The 75th percentile is approximately 40.
Now I will start with the quartiles. The median or the second quartile is the value that lies in the middle of the data. Since there are 10 values, I take the average of the 5th and 6th numbers. That give me a median of 34. The first quartile is the median of the lower half of the data, which gave me a value of 30. The third value is the median of the upper half of the data, which gave me a value of 40. Next, I will find the range. The range is simply the highest number minus the lowest number. So 100 minus 25 give a range of 75. Now I will calculate the variance. First, I find the mean, which is 40.6. Then I measure how far each value is from the mean and square the differences. After adding all the square differences together and dividing by the number of data points, I get a variance of 423.224. Lastly, the standard deviation is the square root of the variance. Taking the square root of 423.24 gives a standard deviation of about 20.57.
Now, let's move on to the box plot, which summarizes the distribution using 5 key numbers. First, minimum 25. First quartile 30. Median is not provided but implied to between Q1 and Q3, means minimum and maximum. Using the interquartile range, we identify outliers values that fall outside the typically range. We calculate the lower and the upper fence. Any value below 50 or above 55 is considered an outlier. In this case, value is 100, exceeds the upper fence of 55, making it an outlier. For the lower fence is 50, and for the upper fence is 100. This analysis is help us to understand the distribution variability and any unusual data points in the dataset.
So, for the conclusion, the descriptive statistic provide a clear overview of the community's income distributions. Additionally, the mean, medians, and mode help determine the typical income level. Furthermore, the range of variance and standard deviations reveal the extent of income variations within the community. Moreover, the quartile and box plot illustrate the spread of the data and highlight any potential outliers. So, for the overall, this analysis enhance the understanding of income patterns and support more accurate conclusions. So, that's all from us.